In this module, we will look at common flange types and when they should ideally be used. Weld neck flanges. Weld neck flanges are used when high strength is required, especially for high pressure and extreme low temperature or high temperature applications. They are also used when the welds required X-raying as part of the QA process. The weld neck flange is the only flange which can have the weld joint radiographically inspected. The design of the weld neck flange reduces high stress concentrations at the base of the flange by transferring stress to the adjoining pipe. This is achieved by the long tapered hub. The flange itself is butt welded to the adjoining pipe, and the bore of the flange is machined to match the internal diameter of the adjoining pipe, because the ID of the pipe and flange match. There is no restriction to flow, and therefore turbulence and erosion are eliminated. Weld neck flanges are the most expensive of all flange types. Slip-on flanges. Slip-on flanges are designed for low and moderate pressures as they are not as strong as weld neck flanges. They are attached by slipping the flange over the pipe and then welding it into position. For low pressures, only the pipe end is welded, otherwise a second weld is applied between the hub and pipe OD. They are easy to fit and align, which makes fabrication costs low. Overall, they're relatively inexpensive and they are most useful when space is at a premium. Lap joint flanges. Lap joint flanges are also known as loose backing ring flanges or vanstone flanges. A lap joint flange requires the use of a stub end which is first welded to the pipe. A backing ring, which has been previously slipped over the pipe prior to welding the stub end, is then brought into position and is free to rotate prior to bolting. The backing ring is not welded to the pipe. Because there is no welding of the backing ring, flange bolt hole alignment is much easier compared to fixed flange types, and this provides advantages when dealing with complicated pipe spools or when frequent dismantling is required. Lap joint flanges are commonly used in stainless steel piping systems, as the use of a stainless steel backing ring in conjunction with a stainless steel pipe is much cheaper when compared to a slip-on flange. Whilst a lap joint flange provides cost, alignment and dismantling benefits, it cannot be used when high external loads or dynamic loads are present. Examples of such loading conditions would be a high torsional stress or high pipe bending stress, significant water hammer, wind loading, earthquake or vibration. These types of loading conditions cause leakage between the backing ring and the stub end purely because the backing ring relies on the tensile force of the bolt to avoid leakage, and there is also an additional leakage path between the ring and the stub which is not present in other flange types. Threaded flanges. Threaded flanges are used in conjunction with threaded pipe ends. The pipe is simply screwed into the flange. Thread tape, or another proprietary thread sealant, is used to take up the clearance between the mating threads. Threaded flanges can be used for a wide, that is high, pressure range for smaller diameter piping at ambient service temperatures. They are quick to install on site and they do not require any welding. Threaded flanges should not be used when they are extremes of temperature, high bending stresses, high torsional loads, or cyclic stresses present in the piping system. Such situations will result in a flexing of the clearance between the mating screw threads, which ultimately results in leakage as well as the potential for thread fatigue and damage. Socket welded flanges. Socket welded flanges are attached by inserting the pipe into the socket and then welding as shown. For heavy service, 2 welds need to be applied. If 2 welds are used, the weld at the pipe end is typically ground smooth to ensure a smooth bore, which in turn reduces turbulence. This gives this type of flange an advantage over slip-on flanges. Socket weld flanges are ideal for high pressure applications involving small diameter piping and are second only in strength to weld neck flanges. Blind flanges. A blind flange typically serves the function of a plug or a cap and is therefore used to terminate the end of a piping system. A blind flange can also be used to seal a nozzle opening on a tank or a pressure vessel, or it can be drilled and tapped so that a smaller threaded offtake can be installed in a T in a main flow line if a welderlet, threaderlet, stub in or set on is not practical. Specialty flanges. The terms adapter flange, combi flange and uni flange are all trademark terms which are owned by their respective companies. These terms refer to a family of flanges which slip over and seal on the outside surface of the pipe in conjunction with an elastomeric sealing ring similar to that used in a rubber ring joint. Imagine you need to connect a plain end pipe to an existing pipe flange spool, and welding, screwing or grooving cannot easily be performed on the job site. The plain end pipe will require a specialty flange, say an adapter flange. The adapter flange is the first component to be slipped over the plain end pipe from left to right as shown in the graphic on your screen. The adapter flange is aligned and lightly secured in position by means of positioning set screws. Next, the adapter flange sealing ring is lubricated and slipped over the pipe end so that it sits within the groove within the adapter flange. The adapter flange and pipe assembly is now brought into contact with the mating flange spool. The positioning set screws are firmly adjusted to centralise the adapter, and flange bolts are then tightened to their correct torque setting. Whilst the adapter flange, combi flange and uni flange have the advantage that no on-site welding or machining is required, it does suffer from some drawbacks. Because the adapter flange has to seal on the outside surface of the plain end pipe, this surface must be in very good condition. If it isn't in good condition, through say scores, scratches, ovality issues or surface deposits, the flange may leak. Secondly, the assembly of such flanges requires a high degree of workmanship than a fully welded flange spool. If the sealing ring of positioning set screws are not assembled just right, the flange will leak. If there are any torsional loads, high levels of vibration, high levels of thermal growth or movement, or perhaps water hammer present in the piping system, the flange may leak. So, at Casa Redberg, we only specify the use of these flanges typically as a weapon of last resort. However, this is just our opinion, and we acknowledge that these types of flanges definitely have their place in simple low pressure piping systems which are well supported and don't undergo any, say, thermal movement or experience anything other than loads due to internal pressure only.